Alrighty, so we're going to go over the Geometry B final exam review. First thing I want to point out that I wrote over in a little box here is that this term we talked both about congruence of triangles and similarity of triangles. So I wanted to make sure you had a reminder of the methods that we have to prove congruence versus similarity. So if you have that somewhere, make sure that we go over that. So from the information in the diagram, can you prove that triangle FDG is congruent to FDE? So what pieces of information other than the three corresponding congruent angles do we know in this picture? Angle is not an option for congruence. We do know that they share a side, DF. So by looking at that, I could prove that they are congruent either by angle, side, angle, or I could use angle, side. So angle, side, or angle, side, angle. Number 2, find the values of x and y. So first of all, we notice that we have two congruent marks here, so that makes this an isosceles triangle. So if this is 46 degrees, so is this. How do I know what's left for the angle BAC? Well, obviously I know the three angles in a triangle add up to 180. So if I subtract 46 twice from 180, I'm left with 88 degrees. So that means that each of these, because they're bisected, is going to be 44 apiece. And obviously, last but not least, 44 and 46 gives me 90, so I also know that x is 90. So x is 90 degrees, y is 44 degrees. Number 3, find the value of x. The diagram is not to scale. Again, I notice that I have an isosceles triangle. So I know that my base angles are exactly the same. So if this angle is 5x minus 30, so is this one. Well, what do I know about this relationship? Hopefully, we remember that these form a linear pair, so they're going to add up to 180. So 5x plus 5x minus 30 is equal to 180. So x is equal to 21. Next description. Alrighty. I made a little mistake there, so I had to pause and re-record. So RQ is the perpendicular bisector to PS at point Q, which is between P and S. So angle SPR is congruent, so SPR, this angle, is congruent to PSR, which is this angle, by which of the 5 congruent statements, HL, AAS, ASA, SAS, and side, 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 can you immediately conclude that triangle PQR is congruent to SQR? So there's a couple things I didn't mark in yet. If RQ is the perpendicular bisector, that means it's bisecting this side as well as it's perpendicular. So those 90-degree angles are also congruent to one another. So we have some options. I also know that RQ is a shared side. So I could call this side angle side. That would be an option. I could use angle side angle. I could technically use angle side. Since this is a right triangle, I don't have the hypotenuse. Well, actually, yes, I do, because if these two angles are congruent, that makes this an isosceles triangle, which means those sides are congruent. So we could use side, 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 or finally hypotenuse leg. So as long as you put the reasoning in there, you really have all of these corresponding pieces congruent. So any of those would actually work. Number 5, what additional information will allow you to prove the triangles congruent by the hypotenuse leg theorem? So first of all, we're given here that the hypotenuse is congruent in each of the figures. So all I need to do is have a set of corresponding legs. So we can either say that DC is congruent to CB, or we could use the fact that AC is congruent to CE. Either one of those would be fine. Alrighty, number 6. If triangle BCD is congruent to triangle FED, what are the congruent corresponding parts? So hopefully we remember that this congruent statement tells us all that information without even having to look at the picture. If B is in the same position as F, I know that angle B has to be congruent to angle F. I know that angle C has to be congruent to angle E. And I know that angle D is going to be congruent to angle D. More specifically in this picture, since we have more than one angle that can be described as D, we'll call this BDC and EDF. Finally, what are the corresponding pieces of the segments? BC is congruent to FE, BC, FE in the same position. CD is congruent to ED. And finally, BD is congruent to FD. For the two quadrilaterals below, angle I is congruent to angle M. Angle IJK is congruent to MJK. So that's that one. Angle LKJ is congruent to NKJ. And angle L, 1, 2, 3, 4, is congruent to angle N. So it says complete the congruent statement for the two quadrilaterals. Which vertice corresponds to L in the other quadrilateral? We have N. What corresponds to K? K. What corresponds to J? J. And finally, what corresponds to I? M. Alright, so next we have two triangles. I'm just going to draw them. So we have RST and UVW. For triangles RST and UVW, angle R is congruent to angle U, ST is congruent to VW, and angle S is congruent to angle V. Explain how you can prove that triangle RST is congruent to UVW by angle, side angle. Unfortunately, with the information we're given, we can't use angle, side angle. However, what piece of information do we need? In order to use angle, side angle, the side has to be included, the one that's directly between. So I need to know that RS is congruent to UV. That would be the additional piece of information that I need. Number 9, complete the statement. BF is congruent to what? Explain why this is true. So if I look at segment BF, I notice right here I have an angle bisectors. So I also know that these segments here will be congruent. So BF is congruent to FE. Number 10, complete the proof by providing the missing reasons. SD is perpendicular to HT is given. SDH and SDT are right angles. How do we know this? This would be the definition of perpendicular. I also have a little issue. I would like to also make a statement that they are congruent, meaning right angles are congruent. They don't have that on this. Okay, SH is congruent to ST. Again, it's also given. So let's make sure these items are marked in the picture. So SH is congruent to ST. So last but not least, what else are we missing here? The reason is reflexive property. So I do know that SD is congruent to SD. Because this is a right triangle, I have my hypotenuse and I have a leg of the right triangle, so these triangles are congruent by the hypotenuse leg theorem. Alrighty, and our next proof. In the figure, angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, and TK is congruent to TL. So all that information is given and in my picture. So they want us to prove that triangle RTK is congruent to STL. So let's talk about what information we feel is missing here. We don't have marked in that TK is congruent to LT or TL. So by looking at this figure, can I use anything to tell me that these triangles are congruent?